Assalamualaikum warahmatullahi wabarakatuh. Today we will present our group assignment of Mathematics 2, BBP 10403, Section 1. Our topic is limit, understanding limit in calculus, concept, problem solving, and application. We will explain the concept, the formula, and show how to solve example questions. This is our group members. Firstly, Muhammad Lokman bin Zulizam, Ahmad Loman bin Muhammad Jamal, Muhammad Asfar Ikwan bin Yahya, and also me, Muhammad Izham bin Azman. Lastly, Muhammad Ahmad Aiman bin Muhammad Rafi. Okay, my part is introduction. I want to explain about introduction. Developing a strong understanding of the concept of limit by analyzing definition, solving problem, and applying limit concept in the real world context. And our objective, firstly, explain key concept of limits. 2. Solve limit problems. 3. Show how limit apply in the real world situations. And lastly, summarize conclusion clearly.
Definition of a limit. A limit describes the value a function approach as the input approach a certain number. Okay, you guys can look at that formula. Okay, now we go to parts one-side limits. One-side limit loops only from one side of a point. Anyway, we have three types of limits. The first one is left-hand limit, values of less than approaching from the left. Second, right-hand limit, values of greater than approaching from the right. And the last, the two-side limit, exists only if both one sides. Limits exist and are equals.
Assalamualaikum warahmatullahi wabarakatuh. This is my part. The title is Infinite Limits. When a function values increase or decrease without bound, it have two formula, positive and negative. The positive is it can be met a bit rarely, large as gets close to, while the negative is mean decreases without bound as gets close to.
So we move to the limit laws. Limit laws are rules that allow us to compute complicated limits using simpler ones, assuming the limits involved exist. So limits law have three laws, which is the first law is sum or difference. The limit of the sum or difference of two functions is the sum or difference of the limits of the functions. Second law is product. The limit of the product of two functions is the product of the limits of the function. And the third law is quotient. The limit of quotient of two functions is the quotient of the limits of the function, provided that the limit of the denominator is not zero.
Okay, I want to explain about squeeze theorem. The squeeze theorem, also known as the sandwich theorem or pitching theorem, is an invaluable tool in calculus used to find the limit of a difficult function by squeezing it between two other functions that easier to handle. For example, g of x less than or equal f x less than or equal hash of x. If the function is trapped between two others, simpler function near specific points. The second, limit g of x equal limit h of x equal else, and if the limit of two order functions are equal at that point. And lastly, limit f of x equal else. Then the limit of the function trapped in the middles must have the exact same limit value. Problem solving. Question number 1. Limit approve x approve 3. X squared 2 minus 9 divide x minus 3. First of all, we must be the know the problem. The problem evaluate the limit of x to x squared 2 minus 9 divide x minus 3 as x approve 3. Step number 1. Direct the substitution yet the independent from 0 divide 0. Step number 2. Factor the numerator. X squared 2 minus 9 become x minus 3 x plus 3. Step number 3. Cancel the x minus 3 factor in numerator and denominator. Step number 4. The function simplify to x plus 3. Step number 5. Substitution x equal 3 into x plus 3. Final answer 3 plus 3 equal 6. The limit is 6.
Okay, now we go to question number 2. We are finding the limit as x approach 0 of sin x over x. First, if we substitute 0 directly, we get 0 over 0, which is an indeterminate form. Next, we use the fundamental trigonometric limit, which states that sin s divided by s approach 1 as s approach 0. To confirm this result, we apply the squeeze theorem since sin x is always between negative 1 and 1. Therefore, the limit of sin x over s as s approach 0 is equal to 1.
Okay, we go to the question 3 of problem solving. Step 1, first we observe the function. We notice that the highest power of x in the numerator and the denominator is the same. This is important because it tells us how the function behave for very large value of x. Okay, we go to the step 2. Next, we divide every term in the function by the highest power, which is x squared. This help simplify the expression so we can see which term matter that as x becomes very large. Next, we go to the step 3. After dividing, we see that the sum terms have the form constant divided by x or constant divided by x squared. As x approaches infinity, this fraction becomes smaller and smaller, and eventually they approach 0. So this term no longer affects the limit. Step 4. At the end, the only terms left are the leading coefficient, 5 from the numerator and 2 from the denominator. All other term has gone to 0. Okay, the final answer. So the limits simplify the ratio of this leading coefficient. In other words, the limit is 5 divided by 2. Okay, that's all.
So we move to the next question is question number 4. For this question, we want to find the limit of the function 1 divided by the expression x minus 2 as x approaches the value 2 from the right side. For step 1, when x get closer to the 2 from the right, the denominator, which is x minus 2, becomes a very small positive number. So we call this positive 0. For step 2, when we divided 1 by this very small positive number, the result becomes extremely large. In mathematics, we say the value approaches positive infinity. And finally, in terms of the graph's behavior, this function has a vertical asymptote at x equals to, and the graph increase without bound as we approach to from the right.
Assalamualaikum warahmatullahi wabarakatuh. My name is Lokman, and today we're going to solve problem solving question 5. Here is the problem. The limit as x approach 0 of x times sine of 1 over x. At first, this look difficult because the sine function oscillates. However, we can use the squeeze theorem. First, we set up an inequality. We know that the sine function is trapped between negative 1 and positive 1. If we multiply everything by the absolute value of x, we get this inequality. Negative absolute value of x is less than or equal to x times sine of 1 of x, which is less than or equal to the absolute value of x. Now, we look at our outer limits. The first one, the limit as x approaches 0 of negative absolute value of x is 0. And the number 2, the limit as x approaches 0 of positive absolute value of x is also 0. Since the middle function is squeezed between these two, our final answer is the limit is 0. Next, let's look at a real-world application, finding the instantaneous speed of a moving car. Usually, we calculate average speed using this formula. Average speed equals to s of t plus delta minus s of t all divided by delta of t. Here, s represent position and a delta t represent a change in time. To find the speed and exact moment we make the time change, which is delta t, get smaller and smaller. This gives us the derivative written as v of t equals the limit as delta t approach 0 of s of t plus delta t minus s of t divided by delta t. Let's solve a specific example. We want to find the instantaneous speed of at time t equals 2 for the position function s of t equals t squared plus 3t. To solve this, we use h to represent a small change in time. We set up our limit. The limit as h approaches 0 of s of 2 plus h minus s of 2 all divided by h. We substitute our function values into the equation that give us a long numerator, 4 plus 4h plus h squared plus 6 plus 3h minus 10 all divided by h. When we simplify the top part, the number cancels out, leaving us with h squared plus 7h divided by h. We can cancel out the h from the bottom, which leaves us with a very simple function, h plus 7. Finally, we take the limit, which is the limit as h approaches 0 of h plus 7 equals 7. So our final answer is the instantaneous speed is 7 meter per second. That concludes our presentation on how limits help us solve theoretical problems and calculate real world. Thank you so much. If you have any question, message us and we will answer it soonly. Thank you very much.